Okay, so I'm just gonna yeah, I'm gonna like I said, I'm gonna address these questions. So med student from Canada, if I do remember correctly, I asked a couple pediatricians about this since they deal with ADHD cases and learning disorders. Prescription amphetamines don't have a significant effect versus placebo, concentration, memory, etc. Increases self-perception of performance. Yeah, I've actually heard the same thing. I remember physicians when I was clinically training would describe, especially pediatric physicians, and at the time, I remember when I was training, I wasn't quite sure what that. It seemed I wasn't sure what that meant, but later in when I did my PhD, I actually did studies on ADHD kids in the 10 to 12 age range using sort of engineered video games. We were trying to sort of remediate or help their ability to focus with these video games. And there's a task you use to assess their attention ability called the TOVA. And it's got three components, and it doesn't. The details probably are a little dense and don't really matter, but basically it's very messy, and I can understand why physicians basically walk away with this sense of it. After, there's piles, there's hundreds or thousands of research articles, and they all kind of say conflicting things because every time you get a different group of 40 people and you study them, you get significant effects on one thing but not the other, and vice versa. So there's just a lot of individual variation in this stuff, and ultimately those tests aren't. They haven't been great for population research, but they are used in the clinic sometimes to see, say, what kind of ADHD you have. So, like for instance, there's I'm gonna blank. It's impulsive. There's impulsive, and then there's like a non-intentive. Like you kind of space out, and those are two different ways they've abstracted it, and then there's a third category, so you have some combination of those two. So yeah, so they basically are looking at these reaction time tests in clinic to see, are you just getting more antsy and wired on these drugs, or are you kind of like zoning out and spacing out, and is this helping you like do that less? This gets in a really like more complicated question. I really should turn off the notifications because that's gonna be really distracting. That's cool. I actually don't do social media very much, weirdly, so that's ominous. So I'm not used to, as somebody pointed out, I just made this Reddit account, so I don't really do Reddit very much. But let me just kill this really fast. Wow, I'm still talking about ADHD. Oh yeah, but this is a there's a bigger, and I saw a lot of questions on this, and I still think maybe one thing might be good is I might try to clip some of these answers if I do the live stream version. Maybe throw up some YouTube videos where I explain some of these topics. I'm still not sure. I don't know how much work it is to edit stuff, but I'm getting a lot of the same questions, so it might be helpful. Yeah. So I guess some people have the problem of, okay. So with this is to make it more applicable to people maybe who don't have an official ADHD diagnosis. There is there is two categories of, you could think of it. There's two things that attention does for you. One is it's inhibitory. You know that. So if you're like if you're in a video game, you want to be really antsy and trigger happy, but you don't want to basically be pushing the trigger button every time anything on your screen changes. So what's happening is your entire circuitry, your motor circuitry is wired up almost as a reflex to fire, and your attention at that point, your sort of prefrontal cortex is intervening as an inhibitory mechanism to stop, and it's trying to act as a stop gate and then let you go if it, say, as like an enemy on a first player shooter or whatever. Like I have this problem sometimes when I'm paying with a credit card machine, and the message changes, and it's like It's I think it says pull your credit card out. And I'm just waiting for it to change, and as soon as it changes, I pull my credit card. Um, and then it's just another message saying, like, leave your card in, and then and so it kind of gets me to, that's an impulsivity problem, because I'm like ready to go, and I pulled the trigger too soon. So it's not necessarily a problem. It's just a different mode of how your brain can work, and so it lets you be faster, which is good, say in a first player shooter game, or if you're like a mixed martial artist or something. um, you're chambering a sequence of events you want to do, and in this case, you're saying like if there's a significant change in your visual range for a first player shooter, you're going to click your finger down and shoot your weapon or whatever. um, and so now you're relying on your prefrontal cortex to basically have a stop gate until the conditions are right. So that's inhibitory control, which is something that you can measure in a very simple but kind of painful cognitive task where you just get flashed a lot of different stimuli, and people uh, um, I don't know if I'm getting way too technical here. Anyway, there's two categories of attention. Let me keep this simple. um, there's the ability to inhibit, and then there's the ability to say focus, to not. So like if you kind of like are a daydreamer, you space out and you totally miss what other people are saying. That's like another category of ADHD, and it's another category of just general attention, even with healthy humans. It's another function of attention, and that's sort of like a meta attention, which is like you're scanning all your senses and your environment, and it's deciding where your attention should be. So it's a meta attention. And I think some of the questions I got would be better understood if people understood the concept of meta attention. I don't know. Maybe we'll get into more later. I shouldn't drill on this too deep. I'm gonna fight my my badly trained academic um, habits. You know, uh, in PhD land, they sort of really encourage you to ramble. So I'm going to try not to do that. I'm going to try to keep this focused. I'm going to keep going through questions, and hopefully, by covering the same things over and over, maybe we'll get there. But if somebody really wants me to go deep on something, I can do that too. All right. Um, oh yeah, I this was a interesting question. This was one I answered already. In the book Mastery by Robert Greene, he cites this book, which I haven't read either of these books. Individual has a primal inclination towards one type of intelligence more than others. Some have visual, some auditory, etc. Do you think this is true? And I've heard this, like, was it kinesthetic, um, which is in cognitive science land, it's somatosensory, which is a combination of really proprioception, which are nerves that are specific, like let me know where my what position my joints are in, even if I close my eyes, because you're actually relying on a lot of visual feedback. Um, but there's nerves that let you know where how bent your joints are and stuff like that. And it's called proprioception. So that um, can be thought of like another sensory type of information. Just like you have neurons that are sensitive to temperature, hot and cold. Um, yeah, so if you start really breaking down sensation, you can get into a lot of different categories. So that's one thing. It's like, then is there something called like hot and cold sensing intelligence? Not really. These are just different kinds of sensations, and that was kind of my gist of my answer to him. And I think a lot of other people seem to agree with that. People who even read the book, so that was cool. Um, I think intelligence typing is like, in colloquially and socially. Obviously, we're all interested in this. Um, it's we like to categorize people this way. uh, I saw a question later on where somebody, I don't remember the specifics, but they were talking about like the the brilliance of athletes, and I mean, there certainly is, there has to be there, and we don't necessarily have great tests to characterize that, and we don't have a great tests to characterize even much more cerebral things either. A lot of our cognitive tests are really almost basic, measuring basic reflexive things. So like They're reaction time based. They're discrimination based, which means you're trying to discriminate. You're getting a lot of times like a bunch of different shapes, and it's like if you time every time you see a circle, hit it. And then there's more slightly more complex things where it's like we want you to discriminate by shape and color. In that case, you're fusing two types of sensory information, even though they're both coming from your eyes. You have different areas in your visual cortex that do essentially edge detection, and then higher levels that take that information and do shape detection. And then separately, you have color areas. So there's those two streams get fused somewhere, still in the visual cortex, probably, or close to the visual parietal areas. This is a common theme of how the brain works. As you go higher up, it's just higher levels of abstraction from the raw sensation, and it's hard the way we talk about intelligence because that is a form of like low level intelligence. You know, there's very intelligent algorithms, say, operating at all these levels, at every level of your brain, and a lot of these are subconscious. So, but socially, when people say intelligence, they're really referring to people's like competence or ability to do something socially relevant. And but then when you talk about computer scientists, they mean um, artificial intelligence. You know, they mean like um, they could mean anything. I mean, if the ability to recognize a cat versus a dog is a is, you know, they like to use that word because it's a hard task for computers, or used to be. Um, so I think the problem with using the word intelligence is there's a lot of conflation of definitions. But anyway, I'm doing the rambling thing again, and I apologize. And I'm just gonna do my best to try to balance my um, comprehensiveness with brevity and not losing people's interest. Um, yeah, so intelligence typing is super interesting, but intelligence itself is already um, a higher level abstracted concept, so that you measure people on a bunch of different things. You know, you've heard of maybe these things like Raven progressive metrics, um, different shape patterns, things. It's a lot of pattern recognitions, and they try to generalize. It's like getting a single GRE score. You know, you have one number, an SAT score or whatever, but they've measured, say, reading and math. So they've collapsed two dimensions. You could be really high on math but really low on reading, or really high on reading but really low on math, and they've collapsed that to a single axis where you just have a number, and the bigger you are, the smaller. So that's all really IQ is. It's a construct that has the psychologists are very proud of it. I'm less um, excited by it. It's moderate relative, validity. Um, for those of you interested, I think he's a bit controversial, but I do like his comments on IQ. Nassim Taleb, I think he had an interesting breakdown. He's a statistician by training, and he talks about the problems with. To summarize this whole thing in one sentence, it's that um, there's a plateau problem with IQ. Like it's really good at detecting low IQ up to average, but high IQ it's sort of a flat line. Like the correlation kind of falls off. Anyway, um, backpedaling out of this topic, unless people are more interested in it. Let me see if there's anything else to this. Individual differences on the ability to process different sensory information. Oh yeah, this is my response to that. Oh, and then he asked about Neuralink, which I will talk about in a minute. Let me see what somebody in chat. If that means you have better brain processing in the lower levels, could you impact your overall intelligence? Yeah, that's a really good question. Uh, yes. In fact, you can go lower than the lower brain levels. So the human cortex, uh, pretty uniformly across your entire brain, is actually just six layers of neuronal bodies. It's a, and there's some variation in different parts, but it's basically six layers. And so, but you get way more layers out of that because once you go through all the layers of the visual cortex, so like V4 very consistently in like 99% of humans, which is the fourth layer of the visual cortex in the back of the head, processes color. V5 processes motion. But so once you hit the sixth layer, you're like, well, you can't get more abstract. But what it does is it sends those neurons to a different part of your brain, mostly the parietal centers, and they start all over. And then you have these specialized columns in your parietal center that like are very good at detecting human faces or locations or such. And then they can even and then they could repeat it and repeat it and repeat it. And so the vast majority of the inside of your brain is actually axonal connections. It's all the so-called white matter. And um, and so certainly your ability to abstract at the highest levels, say your the most prefrontal parietal areas. So you have basically the visual cortex, parietal, and then prefrontal. As you move forward, you get more abstract, and and so like a lot of the things that we associate with uh, like pattern recognition tests on IQ or really say high cerebral remarkable abilities in humans, they're higher prefrontal, and then you get into like language centers and math centers and things like that, or areas that are associated with when you're doing activities in those like math activities versus non-math activities. That's the kind of way they parcelate out the cortex, and a lot of times this is more complicated because it's networks of various. Anyway, it's a great question because it's does better brain processing and lower levels impact your overall intelligence? It does. For I mean the really simple examples, if you're colorblind, your ability to um, you know uh, have higher level discrimination on colors is obviously going to be impacted. That's a very binary, maybe oversimplified example. Um, well, I think what was interesting is there was a study a long time ago showed that baseball players. So baseball has like many layers of competitive selection, and when you get from the minor leagues, I actually was in little league, and then eventually you go up the ranks, and I never got past my little league, but I forget what they call it. There's a bunch of layers, and eventually you get up to the minor leagues, and then the major leagues. So by the time you get to the major league baseball players, they've been selected quite a bit. I mean, there's a lot of there's potentially on the order of 100,000 down to just a handful. I mean, it's you're one in a million at that point or whatever, because there's even self selection before you get into the stuff. So it's interesting because when they studied major league and even minor league players, they all have way above human average vision. Like a lot of them have a better than 20/20 vision. And so the idea is that they're probably able to perceive the baseball coming at them, because the baseball, the pitcher pitches from like, I don't remember the distance anymore, but like 70 feet away at like up to 90 miles per hour. It comes down to like having like a quarter second to really react. And so the better your vision is at that distance, so you can see slight variations in the pitcher's elbow position and things like that. You can hit the ball, which is pretty much every baseball player's one of their functions is to hit the ball. Um, so I think that's interesting because that's even like cortical level, pre brain processing, if you will. Um, or it's the first layers of the cortex and their retina somehow have um, uh, are more sensitive. But in this case, that's just because the lens of their eye or whatever is better even. So you can go all the way down. So that's also an interesting thing because I don't think people appreciate. I think there's a lot of sci-fi examples of transplanting intelligence or brains into other bodies, and there's a complete lack of appreciation of what kind of like bottom up rippling effect that would have on your perception and ability to your intelligence in general and how you perceive things. It's so rooted in the fact that you're in a physical body with whatever limitations it has. Um, so yeah, intelligence is it's a nice abstracted concept that um, it's it, it's nice to refer to, but it's really kind of layered in